Hi everyone, we're going to look at graphing today. So this is your graphing intervention to help you understand motion graphs just a little bit better. Okay, so your assignment for today is to look at these graphs and answer the questions. So let's look at this first graph. So a quick reminder about graphs. We're looking at distance versus time graphs. So for this graph, the line is representing the motion. Remember that a positive slope is a forward motion, a negative slope would be a backwards motion, and a line that is horizontal would represent no motion. Remember that the slope of the line represents the speed, so the steeper the line, the faster it's going. Okay, so let's look at this one. It says, Edward drove 80 miles from his home in London. He stopped and visited his friend Nicola on the way. Here's the distance time graph for the journey. So question A says, how far was Edward from home when he visited Nicola? So we know he stopped and visited his friend. So this is where he stopped. And this is asking for how far, so the distance. So when he stopped, we're going to come over here to the y axis to find how far he was. So this is distance from home in miles. So he was 40 miles from home. Okay, the next question was how long did Edward stop for? So we only want to know how long was he stopped or having no motion. So he was stopped here. So the time is on the x-axis. So we're going to come down here and we only want to know the amount of time that he was actually stopped for. So if we look on the x-axis that has time, it's counting by 1 hour. So that means in between each of these, we're going to be at a half-hour mark. Okay, so every 30 minutes is when we have one of these darker lines. So from 10 to 11:30 is when he was stopped. So that's an hour and a half. So he was stopped for 1.5 hours. Or you can write it 1.5 hours. Okay? Okay, let's look at the next graph. The next graph on your packet today is this one. It says Ellie cycled from her home to her friend's house. She stayed at her friend's house and then traveled home. So let's look at this graph. So here it is, traveling away, then it stops, and then, oh, is it missing something? Let's see what we're gonna do here. So A, at what time did Ellie leave home? So that's on our graph, the starting position. So the starting position of our line is right here. So that is between 9 and 9:10. So that's going to be about 9:05. So 9:05 is when she left her house. Okay, question B, how far was Ellie from home while visiting her friend? So we're going to look at our graph. We have to look at the Y for this one. So here she's bicycling to her friend's house, and we get here is where she stops. So we're going to look at the Y. This is at 8 what? 8 kilometers. So this is 8 kilometers from home. Okay, question C, how long did Ellie stay at her friend's house? So how long is a measure of time? So remember, time is on the X. So when we look at our graph, we're going to come down to the X-axis. So we know she stopped here and here. Okay, so we can look at this from 9:20 to 9:30, and then halfway between 9:30 and 9:40, so that would be 9:35. So she was there for 10 plus 5, so 15 minutes. Okay, the last section here, part D, says Ellie arrived at home at 9:55. Complete the distance time graph. So we are going to look at our graph here. We know that she started at home, so this x-axis is representing her initial position. So we want to get her back home at 9:55. So at 9:55, she's right here. So we'll draw a line just like that. Okay. Okay. Now, you can do graphs number 3 and graphs number 4 on your own to practice your distance versus time graphs. So write everything down, take a picture of it, and upload it to your assignment. Have a great day.